Hello everyone, welcome back to Control Systems lectures. In the previous lecture, I told you about 4 rules of sketching the root locus to determine the movement of closed loop poles of the system as a variable k, which is the open loop gain of the system. It is varied from 0 to infinity. Now, if you have not seen that video, seen the video of root locus part 1, then go to that video, watch it and then come back. Today, I will discuss about the remaining rules of the root locus. But to brief up a bit, what we had seen that we have this rule number 1. So rule number 1 is on the symmetry. So root locus is always symmetric about the real axis. It's always symmetric about the real axis. Then we have rule number 2. Rule number 2 says that the total number of branch of the root locus, it's equal to the total number of closed loop poles of the system. But you will observe that when we discuss or whenever we draw the root locus, we don't actually determine the uh, uh, we don't actually use the overall transfer function. Instead, what we use the GSHs, which is the open loop transfer function of the closed loop system. And if we define this GSHs, then this function, it is defined where it can have where it can have a few zeros in the numerator, few poles in the denominator, and these zeros, they are known as open loop zeros, and these poles which you have over here, these will be known as the open loop poles. Okay, so if we are talking about this GSHs, and then if we have this open loop zeros and open loop poles, then we can also define this rule 2 in terms of open loop zeros and open loop poles. So the total number of the branches, okay, the total number of branch for the root locus, it can be equal to P or Z, where P is the open loop poles and Z is the open loop zeros, but whichever is greater. So if you have a system where the open loop poles, suppose this number is 4 and then open loop zeros it's 3, then the total number of branches in the system, it will be equal to 4 because 4 is greater than 3. But had this been otherwise, like poles was 3 and zeros was 4, then also the total number of branches of the root locus would have been 4 only, because we have to check whichever is greater, or if both are 4, then the total number of branches will be equal to 4 only. Okay, so the total number of branches is determined by you can determine it by closed loop poles also, or P or Z, whichever is greater. Now, the next point is rule number 3. So rule number 3 said a branch of a root locus, it always starts from an open loop pole and it ends at the open loop 0 or infinity, where we assume that the zeros are supposed to be at infinity. I will elaborate a bit on this, rule number 3. Okay, like from where this rule number 3 has come. So that point I want to show. So see, we have got this GSHs. Sorry, we have got GSHs. This GSHs is the open loop transfer function of the system. It can be randomly represented, like it can have some gain k multiplied by, it can have some zeros in the numerator. So s plus z1, s plus z2, s plus z3, and so on. It can have such values in the numerator. Similarly, it can have some poles. So they will be written as s plus p1, s plus p2, s plus p3, and so on. So in general way, we can describe the open loop transfer function. This is the OLTF. It can be written like this. Now, the characteristic equation for the system, it is written as if you want to write characteristic equation. So characteristic equation of a system is given as 1 plus GSHS, this equated to 0. This is the characteristic equation. Okay, and the thus if we want to write the characteristic equation when we have GSHS as equal to this term, so what we can do, we can just write 1 plus to this. Okay, 1 plus GSHS will become the characteristic equation. So what you do, this was equal to k into something plus divided by this, so just add 1 to it. Okay, this will become the characteristic equation, this equated to 0. Now if you rearrange these terms, this will get multiplied to 1 and then it will be taken to the other side. So if you rearrange it, the characteristic equation will finally, it will become like s plus p1 into s plus p2 into s plus p3 and so on, whatever you have, because that got multiplied by 1, plus this first term, that is k into s plus z1 into s plus z2 into s plus z3 and so on, this equal to 0. This becomes a characteristic equation. You can just do this, solve this, so you will come up with this as the characteristic equation. Okay, now the rule that we have over here, the third rule, that the root locus, it starts from the open loop zeros and ends at the root locus starts from the open loop poles and ends at the open loop zeros. It can be understood. Now we say that root locus is defined when the this variable k, this is varied from 0 to infinity. We define the root locus for this particular range of k. Hence, what we can do, we can substitute the value of k as equal to 0, because that's where the root locus is starting, and we can then substitute the value of k as equal to infinite, because that's where the root locus is ending. Now, why are we talking about characteristic equation? What is the reason? Because the reason for using characteristic equation is because the roots of the characteristic equation, these are going to give us the poles of the system, closed loop poles, CL, closed loop poles of the system. And what we really want to derive, or what's the real nature or the knowledge that we want to derive from root locus, is that we really want to find the stability of the system, as we want to see the impact of stability on stability of the system as you are varying the variable k. So we are actually varying we are actually seeing the deviation in the location of the poles of the system when we are varying the value of k. Okay, so hence we are using this characteristic equation. Now, when you have this characteristic equation, this is defining the roots of it is defining the poles of the system. So what we'll do, first of all, we'll keep the value of k equal to 0. Now, if you keep the value of k over here equal to 0, okay, if this value is made to be equal to 0, in that case, this complete term will vanish. So this will become 0. So the only thing that you will be left with is this term, the first term. So it's s plus p1 into s plus p2 into s plus p3 and so on, equated to 0. So it becomes clear that the roots of the characteristic equation, they will come out to be equal to minus p1, minus p2, minus p3 and so on, when the value of k is equal to 0. Okay, and what are these minus p1, minus p2, minus p3? They are actually same as the roots or the poles of the open loop transfer function of the system. Okay, so that's where it's coming, that we say that when the value of k equal to 0, or at the starting point is always the open loop poles of the system. Similarly, we can find out, like if we now substitute the value, this was for k equal value of k, we had substituted as equal to 0. Okay, now let me just change it. We change the value of k to infinity because that's where the root locus is going to end. Now if you keep this as equal to infinity, or I'm just writing this k as equal to infinity, okay, this was s plus z1. So you cannot just solve this equation like this when you are keeping k as equal to infinity. So what you can do, you can take k common. You can take k common. Here we had k. Okay, so what I am doing, I am taking k common from this equation. If I take k common from this equation, then first term I will have to multiply it by 1 by k, and from the second part we have already taken k common, so it will remain like this only. Okay, now if this is the solution that we are getting, now you can substitute the value of k equal to infinity. So this k will go to that side, it will become 0. The first term you have got 1 by k, so it will become 1 by infinity. 1 by infinity will lead this to equal to 0. So this complete term will reduce to 0. So what we are left with is this second term. And what is the second term? S plus z1 into s plus z2 into uh, s plus z3 and so on, this equated to 0. And what are these? These are actually the zeros of the open loop transfer function. So we have this GSHS, the term that you are getting, that term, the roots of it are actually, this is the characteristic equation. So characteristic equation के जो roots होते हैं वो आपके closed loop poles होते हैं. But when we are keeping k equal to infinity, then the closed loop poles are actually becoming equal to the open loop zeros of the system. Hence we say that the root locus, it always starts from the open loop poles and it ends at the open loop zeros or at infinity. That's the logic, like from where we have got this third rule. So I just wanted you to give a brief, like how this has been derived, how this root locus rules have been derived. Okay, and then we have got this rule 4. Rule 4 is a point on the, it basically says that whether a point will lie on the real axis or not, it will depend on the condition that how many number of poles and zeros they will be lying on to the right side of the point, that and that should be equal to odd. Okay, so if that number is odd, then the point will lie on the real axis, otherwise it won't. With these four rules, some of the root locus diagrams, they can be sketched, but not all. So now we will look at the other rules for sketching a root locus diagram. Okay, so these four rules we had discussed in the previous lecture also. Now I am going to explain the other rules of drawing the or sketching the root locus diagram. So fifth one is determination of asymptotes of the root loci. First of all, what is an asymptote in root locus context? We have read that root locus starts from an open loop pole and it ends at an open loop 0 or infinity. Okay. Thus, if there is a case, suppose when we have got 4 poles, okay, if we have got 4 poles, open loop poles, and if we have got 2 open loop zeros, then like it will become 4 poles and we have got 2 zeros. Then the 2 open loop poles will merge at 2 open loop zeros. Then how this other 2 poles, they are going to go to infinity. That's what the concept is, that root locus, it will start from an open loop pole and end to open loop 0. So, or infinity. So if there are no real poles, then these two, if there are no zeros, sorry, then these 2 poles are going to end at infinity. But where and how will the these poles move, how are they going to move? Like in which direction? Because if you talk about infinity, we have got two poles, suppose, and you talk about infinity. So where in the infinity, if this pole it goes to left hand side of the s plane towards this infinity, then it's okay, the system is going to be stable. But if you don't know, like if this pole is going to the right hand side of the s plane, initially the system is stable, but if it's going to right side of the s plane and that too is infinity, then that will be a problem. So you have to actually know, like if they are going to infinity, then which infinity is they are they going, means which direction are they going to follow. So to solve this mystery, we have this rule number 5. It helps a lot. So actually asymptotes are the lines on the root locus diagram which shows the approximate path or the direction which the root locus will follow when the value of k it tends to infinity. Okay. But next question is that if this is the case, then do we have to always find the asymptotes for any for sketching the root locus diagram? The answer is pretty obvious that no. So in this example only you can see that had there been only two poles and two zeros, then there would be no asymptotes because there are no poles which have to go to infinity. So actually whenever the value of p minus z, if it is greater than 0, only then you have to find the asymptotes, otherwise no need. Otherwise you don't have to find the asymptote. Okay. And the total number of asymptotes will be always the total number of asymptotes will always be equal to p minus z. कितने asymptotes होंगे सिस्टम में? तो p minus z. Like यहाँ पे अगर दो poles हैं, like here we had 4 poles and 2 zeros, then the total number of asymptotes will be equal to 2. That is 4 minus 2 equal to 2. So let's now read this rule number 5. Rule number 5 says that the p minus z number of branches, these are actually the asymptotes, they tend to infinity along the asymptotes whose angles are given by, so they are given by angles, so whose angles are given by theta equal to 2q plus 1 divided by p minus z into 180 degree, where the value of q it will range from 0, 1, 2 till p minus z minus 1. So to explain this, I'll just take few values of p and z, then it will be easily understood. Suppose you have got p, z, because that's the number that we require. We want to find the value of p minus z because in this equation and the formula that we have, theta it's equal to 2q plus 1 divided by p minus z multiplied by 180 degree. So you need p minus z, you need q, and hence I'll write q over here and I'll write theta over here. Okay. So suppose we have got 5 poles in the system and we have got 5 zeros in the system. Then p minus z will become equal to 0. As I have already told, like if the number of poles and zeros they are equal, then you don't have any asymptotes in the system. So if this is equal to 0, then don't need to find the value, you don't need to find the asymptotes. So nothing will be found out. Next, let me take the total number of poles as 5. Let me take the total number of zeros as equal to 4. In this case, you can see that p minus z will be equal to 1. Okay, it's equal to 1. Now q it actually ranges from 0, 1, 2 like till p minus z minus 1. So here you can see p minus z is 1. So 1 minus 1. So the value of q that you can take, it's only one value and that value is also equal to 0. So the value of q that you will be taking will be 0 in this case. If you take value of q as equal to 0, then the value of theta will become what? This will become 2 into 0 plus 1 divided by p minus z, it's equal to 1, multiplied by 180 degree, and this value is actually, this will become equal to, this reduces to 0, 1 divided by 1 into 180 degree, hence the value of theta will be equal to 180 degree. Okay. Similarly, now let's take another value. If I take total number of poles, I am keeping it fixed as 5. Now I am reducing the value of zeros. I am taking zeros as equal to 3. Then p minus z will be equal to 2. Now the value of q that you can take, like it will be 0, 1, 2, till what value you have to take, it will be p minus z minus 1. So p minus z is 2 minus 1, so it will be 1. So the values of q that you can take now, it will be 0 and 1 only. So this will be 0 and 1. Now if this is 0 and 1, now again find the value of theta. So find the value of theta for q equal to 0 and then find the value of theta for q equal to 1. So we will get two values of theta. First will be 2 into 0 plus 1 divided by p minus z, it's 2 into 180 degree. Okay, so this will become 1 divided by 2 into 180, that is 90 degree. So first value of theta that you are getting is 90 degree. Similarly, take 2 into second value of q, you have to take as 1. So 2 into 1 divided by 2 multiplied by 180 degree. So this will become, sorry, यहाँ पे plus 1 भी आएगा. So this will become 2 plus 1, that is 3. 3 by 2 into 180 degree. Hence this is going to become equal to 270 degree. So the first case you got theta angle. Okay, इस केस में अगर हम S plane बनाते हैं, so if we draw this S plane, the asymptote is actually 180. It's at the angle of 180 degree. So I can say that the pole, it will be moving, like suppose wherever you have the pole, it will be moving towards infinity, but to which direction? Towards 180 degree angle. So towards this direction the pole will be moving. This infinity it's going to be moving. In the second case, similarly, here if I want to define the asymptotes, you have two asymptotes over here because p minus z equal to 2. One of the asymptote, it will be moving about, both the asymptotes will be moving to infinity, but along which path, which direction? So this one will be moving, one will be moving towards positive, like positive infinity, this is 90 degree, and another asymptote, it will be moving towards 270 degree. Okay, this will be 270 degree. So one pole will be moving towards this direction, other will be moving towards this direction. Similarly, you can always change the values. If I change this to 5, I change this to 2. So now p minus z will become equal to 3. The values of q you have to take will become 0, 1 and 2. The angles you can again find it out. So you'll find that like these angles will be 60, 180 and 240. So in this case, if you draw the S plane, the angles, so you can say that one of the pole will be moving towards 60 degree, another will be moving towards 180 degree, another pole will be moving towards 240 degree. Okay, so these are the directions along which the poles will be moving. So now you can get the idea like where, in which infinity that pole is going to move. So I guess it's clear now, this rule, rule number 5. Next come to rule number 6. Now this is again part, like 5 and 6 you can club it actually because they are dealing with the same point. This centroid rule is also related with the asymptotes. Asymptotes you are going to find out only if the value of p minus z, or you can say mod of p minus z, it's greater than 0. If the values of poles and zeros, they are equal to then you don't have to find the asymptotes. So centroid, rule number 6, centroid, it is the point of intersection of asymptotes with the real axis and is given by some formula is given over here. So actually what we saw in the previous rule was that we have to draw the asymptote, but the point where it intersects in the real axis, like here you saw, we have given the angles, okay, like one of the asymptote it's going to 60 degree, one is going to 180 degree, another is going to 240 degree, but the point where they are meeting at this real axis, it was not defined कि ये कहाँ से, ये यहाँ से भी हो सकता था, इस पॉइंट से भी हो सकता था, ओके, ये यहाँ पे 90 डिग्री 270 है, तो ये यहाँ से भी हो सकता था 90 एंड 270 डिग्री. So the point where these asymptotes they actually meet on the real axis, that point should also be known, and that point, this point that where it's meeting on the real axis, this point is known as the centroid. So the centroid, the formula for centroid is given. It is actually the sum of the real part of the pole minus sum of the real part of 0 divided by pole minus 0. So if you suppose have, for example, if you have got two poles, okay, the values, real parts of them are -2 and -4 suppose, and you have got two zeros, the value of it, or suppose take it as 1 0, because only then you will have asymptote. So 1 0, it's having the real part as equal to -3. So the centroid will be located like sum of the real parts of poles, so it will be -2 -4 minus sum of the real parts of 0, so it will be -3 divided by poles minus 0. So total number of poles is 2 minus total number of zeros is 1. So this will become -6 plus 3 divided by 1, so it will become equal to -3. So this -3 is the centroid of the system, okay. This will be the centroid. As you know, like here we have taken pole minus 0, that's equal to 1, ठीक है. तो ये वाला केस होगा, ये वाला केस, this case. So from -3 the asymptote will be directed. This will be the centroid where this actually meets with the real axis. Okay. Next is rule number 7. This is breakaway or break-in point. So these are the points. These are the points where the multiple roots are present. They can be obtained by differentiating k with respect to s, that is dk by ds, and equating to 0 and actually finding the roots of it. So that will give you the breakaway or the break-in point. So when two or more root loci they meet at a point, and when they change direction, then this is known as the breakaway point. Like suppose you have got, suppose this is the S plane and you have got two poles, okay, and it's moving like this pole is moving towards right hand side, this pole is moving towards the left hand side, this is again moving towards right hand side, and then they meet at a point. So they are meeting at a point, and after this point they are separating. So they are separating, one pole is going towards positive infinity, another one is going towards the negative infinity. So if this is the case, then we are defining breakaway point, like this will be the breakaway point. As the name suggests, breakaway. I will break away. So it's a part of the and this is the part of the root locus diagram. So how to find this point where the two roots they are meeting and then they are changing direction? This can be found out by doing dk by ds equal to 0, finding the solution for this. So that will give you the breakaway point. For example, let's explain this with respect to an example. Suppose we have GSHS, that is equal to k divided by s into s plus 2 into s plus 4. Suppose this is the open loop transfer function of a system. For this system we have to find out the root locus, we have to sketch the root locus diagram. Okay, so it will be better if we go step by step, like all the rules that we have seen, we'll go step by step. So rule number 1, it said that root locus is symmetric, so we don't, you know, like it will be having a symmetry. Second one is the total number of branches of the root locus. So the total number of total number of branch will be equal to P or Z, whichever is greater. So here you can see you have got poles which are lying at 0, -2 and -4, and then you don't have zeros. So total number of zeros is actually equal to 0. So this is actually 3. We have got 3 poles and no zeros. Hence the total number of branch in the system, it is going to be equal to 3 because 3 is greater than 0. Hence the total number of branch of the system will be going to equal to 3. So this is the first information that we are getting. Next rule that we had learned, like the root locus, it always starts from the open loop poles. So the starting point will be equal to 0, -2 and -4, and they always end at zeros or infinity. So here, as total number of zeros are 0, hence the ending point will be infinity, infinity, infinity. So these 3 poles, they will actually end at infinity. Okay, so in this case you can easily say that definitely the system will, we have to determine the asymptotes. Now rule number 4 we had seen, it was actually about whether a point will lie on the real axis or not, determining whether a point will lie on the real axis or not. So that will be our next step. So let us briefly draw the this one in S plane. If this is the S plane, so you have got 3 poles. One is at 0, another one is at -2, another one is at -4. So this is -2, 0 and -4. Okay, whether a segment will lie on the real axis or not, it is determined by looking at the like, if you want to find out like if a point will lie on this segment or not. So just see towards the right of it how many total number of poles and zeros are present. If that number is odd, then the segment will lie, otherwise it won't. So towards the left hand side of towards the right hand side of this, there are no zeros or poles. So the total number of zeros and poles is 0. The 0 is actually considered as even. So root locus will not lie on this segment at all. Okay, in this real part segment, the root locus is not going to lie. Now similarly check some between these 2 points, like these 2 poles, you can check ये segment आपके root locus का हिस्सा बनेगा या नहीं, that's what we are talking about. तो take any point, just look towards the right to it. Okay, if you look towards the right, then you can see that there is one pole to the right of it. One pole means odd number, hence you can say that will be true for this entire segment. Hence I can say like this complete segment, इसको हम green signal दे देते हैं. Okay, this complete segment, this I am giving it as green signal. यहाँ पे आपका root locus lie करेगा. Okay, and this one, this complete segment, it was given red signal. Okay, यहाँ पे आपका root locus lie नहीं करेगा real axis पे. So I am representing red like it won't lie. Green signal means it's going to lie. Again you see like towards the right side of this there are 2 poles, hence the number is going to be even. अगर even है तो यहाँ पे आपका root locus lie definitely नहीं करेगा towards this segment. यहाँ पे रूट लोकस लाई नहीं करेगा. And then you see towards the left of it, like if you take a point over here and check, then you have got 1 pole, 2 pole, 3 poles. That number is odd, hence root locus will lie over here. Okay, so I'll just this is how this is one of the information that we can draw using the 4 rules that we have. Now next rule जो हमने पढ़ा, that was about asymptote. Definitely this system is going to have asymptote. Okay, कितने asymptotes होंगे? It is determined by p minus z. So p minus z value is equal to 3 because total number of poles is 3, total number of zeros is 0. So you are going to have 3 asymptotes. अगर p minus z 3 है, so for this condition we had already seen, like I had derived. यहाँ पे देखे थे p माइनस जेड की वैल्यू अगर 3 है तो आपके पास एंगल्स जो आएंगे वो होंगे 60 डिग्री, 180 डिग्री एंड 240 डिग्री. सो देर आर गोइंग टू बी 3 एसिम्प्टोट्स लाइक दिस, बट देन यू हैव टू फाइंड आउट द सेंट्रॉइड. तो सेंट्रॉइड निकालने का फॉर्मूला क्या था? यू हैव टू फाइंड आउट sigma is given by sum of the real parts of the poles, so it's 0, minus 2, minus 4, minus the total number of zeros minus the sum of real part of 0 divided by pole minus 0. So you have minus 6 divided by 3, or this is equal to 3. So at minus 3, this point minus 3, your centroid is going to lie. I should not make it cross. I'll just denote it by a dot. Okay, here your centroid is going to lie, and the asymptotes will be drawn from this point only. So one of the asymptote, it will be drawn with an angle of 60 degree. तो आप एंगल यहाँ से लेंगे 60 डिग्री का. दिस विल बी वन ऑफ द asymptote I am drawing it with yellow. Another asymptote, it will be towards 180 degree, okay, and another asymptote, it will be towards 240 degree. So this is how these are the lines along which the 3 poles are going to move when k will tend to infinity. Now next, rule number 6. Rule number 6 था हमारा breakaway point जो हम डिस्कस कर रहे थे. Now breakaway point is actually it can be determined using if you find out dk by ds. Okay, you have to find out dk by ds. So here the example that I have taken here, GSHS is given as k divided by s into s plus 2 into s plus 4. The characteristic equation can be written as 1 plus GSHS. Okay, characteristic equation can be written as 1 plus GSHS equal to 0. So I can write this thing, I can write here, I am taking it over here. So 1 plus k divided by s into s plus 2 into s plus 4, this equal to 0. This is the characteristic equation. From here I can actually find out what is the value of k. k की क्या वैल्यू होगी ये हमको यहाँ से मिल जाएगा. So the value of k from here, it will become equal to this minus 1, this one will go here, so minus 1 multiplied by this complete term. So this will become minus into s plus 2 into s plus 4. Okay, so this, if you solve this, you can solve this easily. This will become minus s cube minus 6s square minus 8s. Okay, so this is k. If you find this k, then what you have to do, you have to actually determine dk by ds. So just differentiate this with respect to s. So if you differentiate this one, it will become minus 3s square minus 12s minus 8, this equal to 0. You have to equate this to 0 and then solve for this. Now you can use calculator and just quickly solve for this. The values that you will be getting, they will be the breakaway point. So I've just solved it, and the values of S that we are getting is minus 3.15 and minus 0.845. So you are getting 2 points actually here, and these 2 points are breakaway points. But there is one logic over here that you always have to use. Like here, these breakaway points, I said that these lie on the root locus. Okay, जो आप root locus diagram बना रहे हैं, breakaway point उसका part होता है. So one point you are getting as minus 3.15 and another one is minus 0.845. हमने यहाँ पे zones डिफाइन किए थे. लाइक रूट लोकस जो है वो एक तो यहाँ पॉजिटिव साइड में कहीं पे भी लाई नहीं कर रहा था, इसको हमने रेड मार्क किया था. देन बिटवीन -4 एंड -2 ऑल्सो रूट लोकस वॉज नॉट देयर, इसको भी हमने रेड जोन मार्क किया था. बट हियर ब्रेकअवे पॉइंट यू आर सीइंग दैट इट्स -3.15. सो -3.15 आपका यहाँ कहीं लाई करेगा, एंड दैट कैन नॉट बी द पार्ट ऑफ रूट लोकस. So it's not compulsory. Like if you are getting it over here, then you mark it over here, it will become wrong. So this you have to take care. It's not necessary that whatever solution that you are getting from this doing dk by ds, the solutions that you are getting, they are it's not compulsory that they are breakaway or break-in points only. Okay, तो यहाँ पे आपको दो solutions भले ही दिख रहे हैं, लेकिन the only value that you have to take here, this is minus 0.845. This is only the breakaway point. This minus 3.15, it breaks the fourth rule. ठीक है, fourth rule को ये follow नहीं कर रहा है, hence we cannot take that one. You have to only consider minus 0.845. So minus 0.845 will lie somewhere here. So that is minus 0.845. This will be the breakaway point. ठीक है. Now when you get this knowledge, you know that root locus, it starts from open loop poles. So we had two open loop poles over here. Okay, we had two open loop poles, three open loop poles, -4, -2 and 0. It will end at open loop zeros. ठीक है, तो हमको ये पता है कि open loop zeros पे end होगा, as there are no open loop zeros and is going to be placed at infinity. कहाँ infinity में? So one infinity is towards 180 degree angle, another is towards this 60 degree angle, another one is towards this 240 degree angle. And ये कहाँ ये lie कर सकते हैं, that also we know using this green segments. Now you can intuitively now get it, like how these poles they are going to move. So this pole -4 that's over here, it cannot move towards this side क्योंकि ये आपका रेड वाला जोन है, यहाँ पे आप मूव नहीं कर सकते हैं. एंड द ओनली डायरेक्शन फॉर दिस -4 इज टूवर्ड्स दिस ग्रीन साइड, एंड वन एसिम्प्टोट इज ऑल्सो डायरेक्टिंग. लाइक ये ग्रीन भी है, मतलब यहाँ पे लाई कर सकता है टूवर्ड्स माइनस इंफिनिटी, एंड वन ऑफ द एसिम्प्टोट इज ऑल्सो लाइंग टूवर्ड इट. सो आई जस्ट मेक दिस बाय पिंक. सो माई पिंक लाइन इज एक्चुअली शोइंग द रूट लोकस. तो आपका जो ये पोल है -4 पोल है, एज द वैल्यू ऑफ k इट मूव्स, वी वेरी फ्रॉम 0 to infinity, this pole is going to move more and more towards the left hand side of the S plane. Similarly, now you see we have got two other poles. One pole is -2, another pole is at 0. ये दोनों कहाँ जा सकते हैं? This -2 it cannot go towards this side because it's red. This 0 it cannot go to this side, it's also red. So these two are going to move towards this side only. Okay, जो -2 है इसके पास एक ही डायरेक्शन है, to move towards the right, एंड ज़ीरो दैट यू हैव ओवर हियर, ये वाला जो पोल है इसके पास एक ही डायरेक्शन है टू मूव टुवर्ड्स द लेफ्ट. So these two are actually going to come. This is the point of breakaway because these two are coming and then they are going to break away. Breakaway point we have already seen that it's at minus 0.845. अब जब यहाँ से break होगा, these two will break, then in which direction will they go? So for that we have already seen these, we have already drawn these asymptotes. These are the lines along which these two poles are going to move. So one of the pole, it will move towards this asymptote, इस asymptote के साथ move कर जाएगा, ये जो direction बता रहा है, and another point it will move with along this second asymptote. ठीक है. So this pink diagram that you are seeing over here, this is actually the root locus. So if I remove all the other parts, if I just draw the root locus जो pink वाला section बता रहे हैं, बस उसी को अगर मैं draw करूँ, so let me draw it again. This was 0, this was -2, this was -4. ठीक है. So now this -4 will be going towards minus infinity. This will go to this side, this will go to this side. Okay, so you should always draw the directions. They will break away at this point. This point is 0.845. Then one will go towards this direction, another pole is going to go towards another direction. So as k is being varied from 0 to infinity, this is how the roots of the system they are going to move. Now interesting point you can see, like initially you can see we had three poles 0, -2 and -4. System was actually stable system, but you can see then this pole started moving towards the left and this started moving towards the right. This pole went to the left only. Now after we increased k, like we are increasing k and these are moving, we increase k further, so one of the pole is moving towards this side, another is moving towards this side, this is moving towards this side, and so on. When we are increasing k to after a certain level, these two poles they are actually going towards the right hand side. And what will happen if these poles go to the right hand side of the S-plane? That means that the system is going to become unstable. So if we know like at which point of which value of k is it that after that this system is becoming, then it will become very clear to us like how to design the control system. As a control system design engineer, it becomes very clear to us if we have got this kind of root locus diagram in front of us. अगर ऐसा डायग्राम आप बना लेते हैं और ये आपके सामने है तो आपको बहुत क्लियर हो जाएगा कि अच्छा पोल्स को आप जैसे जैसे यू आर वेरिंग द वैल्यू ऑफ के, पोल्स का लोकेशन किस तरीके से मूव कर रहा है. अगर आपको ये मूवमेंट पता चल जाएगा देन यू कैन ईजिली डिफाइन लाइक कौन सा वैल्यू ऑफ के किस चीज़ के लिए कितना सूट करेगा, दैट यू कैन इजीली डिटरमाइन.